Hi, this is a tutorial for scale ratio. It's really just like scale factor, but just in a different format. It's often used for maps and scale drawings. For instance, if I have a scale ratio of 1 to 25, that would mean that any 1 centimeter or 1 inch or whatever it may be in the picture or map really represents 25 of that same thing in real life. So the real life drawing, the real life item, is 25 times bigger than the picture. Now, because of the way this is flip-flopped, normally we put real life on the left and picture on the right. The easiest way to fix this problem is to turn this ratio into a fraction. So 1 to 25 is really 1/25. So that means now the picture is 1/25 of the real life object. So if I were to set this up with a scale factor, I would have my O for my old or my original going to my new, and whatever my original real life item would be, I would just multiply it by 1/25 to get the smaller version. So really that's the only difference with scale ratio. It's just that it's written as a ratio instead of using a fraction or a regular number. Now let's practice this. One example that you might see for using scale ratio is by using a scale on a map. It really looks just like a double number line. You see what matches up with what, and you can find the things you're missing. So in this case, the only ones that we see are 0 matching up with 0 and 4 matching up with 1,000. That 4 actually represents centimeters on the map, whereas the 1,000 represents meters in the actual. So let's go ahead and solve the first problem. If the distance on the map is 7 centimeters, how far apart are the two places in real life? So 7's not even on here. But since this is basically a double number line, I'm just going to fill in the pieces that I'm missing. So because it's counting by ones, which it doesn't have to, but in this case it is, this is going to be 5. This is going to be 6, and this is going to be 7. Now, I can't jump straight from 4 to 7, can't go to 5, can't go to 6. I don't know any of those things yet. However, I can start working my way backwards. And I know that if I cut the 4 in half, I can get to the 2. So I do the same thing with the 1,000. So this is 500. Now I'm going to keep going with that because I know that if I were to cut that in half again, this is going to be 250. Now notice how I'm treating this basically like a ratio table, which I'm allowed to do. A double number line is really nothing more than a ratio table, but with everything organized in order. Whereas the ratio table, you can do things in whatever order that you want. So I'm going to go ahead and draw my arrows because it makes things easier for me. Now at this point, I can see the 1, the 2, and the 4. I don't really need the 3, but I could do it if I really wanted to. And the 3 would be the 1 and the 2 put together, so it would be 750. So from this point, I could tackle this problem a couple different ways. I could just combine any columns that I know are going to get me to 7, or I can just start counting my way up. I see that for every 1 centimeter that I have on the map, it's really 250 meters in real life. So I can just keep adding on 250. So it would next be 1,250, then it would be 1,500 or 1,500, then it would be 1,750. So my answer is 1,750 meters. Or I even could have just done, now that I know the 1, 250 times 7, and it still would have given me this same answer. Now, this is a two-part problem. The next thing they ask us to do is to find the scale ratio. Now, if I were to just write the ratio as 4 to 1,000, that wouldn't be correct because this 4 is centimeters, whereas this 1,000 is meters. So there's a couple different ways that I could tackle this problem. I could turn it into a scale factor problem, but my numbers would probably get really ugly because these numbers are really far apart from each other. 1,000 is a pretty big number. Or I could solve this a lot easier than that. First thing I need to do is convert these so that they are both the same unit. Now, 1,000 meters, that's a really big number. But it's actually about to get bigger, because for every 1 meter that you really have 100 centimeters. Because we know that 100 centimeters equals 1 meter, because centi means 100. So that means that this 1,000 meters is really 100 times bigger than that if I'm working with centimeters. So it's really 100,000 centimeters. Now technically I have a scale ratio right now, but I prefer when I'm doing a scale ratio to have my numbers so that the first number is always going to be 1, but I can do that pretty easily. All I have to do is do the bad date strategy and work my way till I get to 1. If I were to divide this by 2 on both sides, I would get 2 centimeters, matches up with 50,000. If I wanted to get down to 1 centimeter, I'm just going to divide it in 2 again. And I'm going to get 25,000. So that means that my scale ratio is 1 to 25,000, which really isn't that bad. Here's our next problem. This one is definitely a multi-step problem. Even though it doesn't have A and B, you still have multiple parts you have to solve. Because we have a room that is 6 meters by 5 meters, and we need to do a scale drawing that has a ratio of 1 to 50. Now, the reason why this is going to be a 2-part problem is because it asks for the dimensions to be used for the drawing. But I need 2 dimensions. So I'm going to have to solve the problem involving the 6 and solve the problem involving the 5 in order to get this right. So let's get started. 6 meters is the actual real life room. So that's going to go in my circle. Then I'm going to be multiplying by my scale factor, which I don't know what it is yet. But I'm going to end up at my new, which is the number I'm looking for. Same thing for the 5. I'm starting with 5 meters. That's my original room. I'm multiplying it by the scale factor, which again I don't know yet. And I'm going to get my new, which is the dimension in the drawing. Now, as I told you earlier, when you see a scale ratio, there's really nothing more than scale factor but written as a ratio. So when I see 1 to 50, that means that I have 1 in the picture or the drawing or the map, and then 50 in real life. But if I switch this over to a fraction, 1/50th, that means that the shrunken version, or the drawing, is 1/50th the size of the real life object, in this case a room. Now, multiplying by 1/50th in my calculator, I could do by using the special buttons, but I could also just as easily convert it over to a decimal by dividing top by bottom. And when I do this, I get 0.02. So that means my scale factor is 0.02x. But that's not what it asked me for. It asked me to find the dimension, so I actually have to plug that in. So I'm going to multiply both these problems by 0.02. Now, when I do this, I'm going to get 0.12 for my meters and 0.1 for my meters. Now, when I have numbers like this where I have a decimal version for my meters, it makes more sense to convert it over to centimeters. And we learned earlier that there's 100 centimeters in every 1 meter. So all I really have to do is multiply by 100 and I'll get the correct amount of centimeters. So I'll get 12 centimeters. Erase that. And I'm going to get 10 centimeters. So my answer is just 12 centimeters by 10 centimeters. That's all you have to do. Good luck in the future.